Let's start. So, a few organizational things. This talk was supposed to be in English, but because it's a Polish conference, I'd like to ask you if there is anyone who'd like this talk to be still in English, or should we switch to Polish? Please raise your hand if you want it to be in English. One person, right? Okay, two people. Okay, so yeah, let's continue. Let's continue in English then. I've got some swag from the Confit organizers to give away. So if you have some questions, I don't plan to ask any. I don't plan to have any quizzes or stuff like that. So if you have any questions, or you may ask some questions at the end, you may want to get one of these. There is also a lean coffee that's going to be held around 1 p.m. I believe. So if you have more questions about the presentation, about the concept that I'm going to talk about, feel free to ask there, or organize kind of group in there to talk about it a bit more. Okay, so let's start. I'm Michał. I'm from Software Mill. By the way, how many of you know Software Mill or heard about Software Mill or using our stuff? Open source things or things like that. Okay, few of you, that's good. I'd like to talk a bit about event sourcing and things I wish I knew before starting a few years ago with event sourcing. And the plan of the talk, I'd like to tell you kind of a story. The first gonna be a story of two features in some kind of imaginary team. Then a bit of debugging, auditing, and kind of meat and like the nature of the core of the event sourcing. Then stuff about the long-term maintenance and long-term development of projects that are event sourced and based on event sourcing. Then how the data consistency patterns work in there. Performance, a bit of scaling the application, scaling the load, and approaching that issues. And there is a section at the bottom, 3 points. There are kind of bonus points. I don't believe we'll have a time to go through these, but if time permits, we'll have a few more options to discuss. By the way, all the drawings that you can see on the right are done by my kids. When they heard that I'm going to give a talk on a conference, they were, okay, we are going to draw you some pictures for that stuff. And I didn't know that it's going to be that hard to explain the concept that they need to draw to them. So if there's something wrong with the pictures, it's not me, it's them. Okay, so let's go with the story. So first meet the Coder Joe. The Coder Joe is a developer in kind of fintech startup, working in an investment space, dealing with money, dealing with bank accounts, exchanges. It can be regular currencies, it can be cryptocurrencies, whatever. So he works as a developer, as a kind of team leader, working in a team, fast-paced startup. They are growing, they are adding new features. And here the story starts. There's a new feature request, because everything nowadays is gonna have needs to have these co-pilot things, which are AI-based or ML-based. So there's a feature from a business people that the user wants to benefit. User having his account with some money in there, wants to benefit from some AI machine learning insights and get his portfolio or balances in several currencies adjusted every, let's say, 7 days. Like automatically adjusted to gain a bit more, to make more profits from the market. So if something is up, just sell a bit of it and buy something that is buy a coin that is deep. The company wants to have this feature, but user will pay for that feature extra. But on the other hand, the company also pays for all the exchanges that it does. So they need to kind of trade off. They need to set the threshold, the balances, from which user is kind of eligible for that adjustment. So there's going to be kind of X amount, let's say of euro, whatever, that the feature is going to trigger. I mean, the adjustment is going to trigger. Sounds easy. So let's ship it. There's a first version that our Joe is going to code. It's kind of pseudocode. It's not any special language, but you can kind of see where it's going. If the adjustment, if the balance is bigger than the expected, than the set threshold, prepare the adjustment, so ask AI, whatever, ML, black box, to give you the recommendations. If it's going to be skipped, because the AI model said so, you just skip it and schedule the next one. If it's not going to be skipped, meaning it's AI advised to do the adjustment, it's going to be executed somehow. That's one of the versions, but on the code review, Joe got an information, like feedback that, okay, if it's going to be skipped, let's save this information about the skip. Okay, so he's adding this else clause, saving this skip adjustment. So we are covered. Whenever we do adjustments, we have the info. Whenever we are skipping the adjustment, we also save the info about the skipped adjustment. It's all good. We are shipping it to production. It works for a few months now. And then people from the product team or people from the business come to our office and ask, we would like to ask a question. We would like to know, we'd like to have a kind of report of last few months of the feature working on production. How many skipped adjustments were there that were really close to that X, to that threshold that we had? Because we would like to fine-tune the parameters, because maybe there are tons of people that are just near to cross the threshold and be eligible for the adjustment, so that we'll have more profit from that. So can you give us the report? How many of these were there? And we are kind of sorry, because we don't have the data. Because we just did the adjustment, we just skipped the adjustment with just too low balance or whatever, but we don't have the data. We don't know how many of these were there. If only we had a log like this, something like that. It's not like precise receipt for the actual log. If only had something like this. So if we were able to have these three flows, let's say. The first one will be when the adjustment is triggered, it gets skipped because of the low balance. Then it gets skipped because the other option is it gets skipped because of AI told us that it's not recommended, it's not worth doing at the moment. And the third one is that actual adjustment was executed. If only we had something like that. And again, that's easy. While saving the skipped variant in the code I showed you before, we can have the additional table, additional column, whatever, and save the information about that. What was the balance? What was the reason? When it happened? Things like that. New table, new column, it's done. Or even we can send a message to Kafka, because it's still an event, right? By the way, maybe one question. First question that may be worth a cup. What would go wrong? What can go wrong when you save to the database and send the message to Kafka at the same time? Anyone?
Database fails.
And what happens? And what happens with the message to Kafka?
It goes to Kafka.
And what happens with your data consistency? You are doomed. Yeah, okay, you got the mug at the end. So yeah, but anyway, we can send to Kafka, we can overcome that issue, obviously, kind of outbox pattern, if you know, there's going to be a talk about the outbox pattern from what I remember. But yeah, that sounds easy. Just adding a bunch of information to the extra table, it's fine. Shipping it to prod works for several months. It looks good. We can get the report after next 6 months. We can get the report. If the business comes to us, we have the data. The next thing, instant smart trader. Next feature that's going to be implemented. It's pretty similar, but it's way more aggressive than the one before. The account is kind of constantly monitored and is doing kind of speculative trading, let's say, very often, depending on some kind of AI ML stuff, because everything is going to be powered by AI these days. So again, company takes profits from the executions, but also pays for the executions on like external exchanges and any other venues. And the adjustment decision is based on different conditions, like account drift, like market conditions on several exchanges, stuff like that. So it's pretty much the same, but slightly different. It gets coded as a separate feature for various reasons. But the thing is that Coder Joe is on vacation. By the way, I don't know why the most color-intensive picture is the one with the vacations, but still. So Joe is on vacation. The coder Bob, new teammate, takes over the feature implementation. And he codes all that stuff in a similar way as Joe did before, but he forgets to save this additional data because he didn't know about it. There's a kind of competence silos in the company. So he didn't know that there was this new table, let's say, metadata about skipped transactions added. And the PR gets approved, and they ship it to production. The feature works, but then again, after a few months, business people come to the room and ask for some of the insights from the past. And again, because we don't have the data, we didn't save the data over time. It's this additional, we didn't do this extra step over time. We still don't have a good answer for them because we don't have the data. We don't have the source to work on. And this is the story about the event sourcing. And if you are a bit interested about the event sourcing, maybe you may know Oskar Dudic. This is the kind of event sourcing guy on the Polish scene. And this is what the quote from one of the conferences he was at. Event sourcing is architecting for tomorrow's questions. And this is very true, and I believe that's what should be in every single event sourcing talk from now on. And I'll try to tell you why and how it works briefly at the moment. So how it differs from the thing that I just showed you, these two features. So how the event sourcing works? You have the user, and the user issues a command, kind of request to do something in our business object, in our system. It may be exchange, it may be withdrawal, it may be deposit, if you are talking about the accounts. There's a command, and then when the command arrives to the system, there is this kind of cloud. It's modeled as a cloud on purpose, because that cloud, that state is kind of a transient state that is being rebuilt from the past events, past facts that were recorded for that given entity, for that given business object that we are working on. So all the events from the event store, from our storage, are being fetched. They are replied one by one. So kind of history is being replied up to the moment, up to now. When all the events are done replaying, we have this state, this transient state that is in form of this cloud. And on this state, we are acting on this state, handling this command. And handling this command may or may not issue some more events. So if the command was okay, if something business-wise happened in the object, we may want to emit some more events. And the events get stored to this event store. And again, if new command comes in, all the events, including these new ones that were saved for the previous command, are being replied. The state is up to date, and the new command acts on the new state. Okay, but this is the part when we only have this kind of right side of that. We can issue command, but there's no way for the user to see what happened, what's the balance change, if the settings he wanted to disable or enable was actually disabled or enabled or not. There's one more thing in the event sourced part, event sourcing systems. There's a read side, which is sometimes called read models, projections. There are different kind of flavors of it. And that side reads from the event store and builds a projection that are, let's say, user-facing or use case specific. So in this case, there may be a data for the user to show his settings, the feature enabled, disabled, account balance, or stuff like that. There's one thing that is crucial in the line between event store and the read side, is the eventual consistency that usually happens in here. Like between applying command and the read side getting the information, the data are not strictly consistent. It's usually not the same transaction, like physical transaction, database transaction. It may look scary, but as I'll show you later, it gives you way more flexibility in terms of scaling, performance, and in terms of architecting the entire system. The next part, like the part on the same level as the read side, are all the event handlers. So whatever happens in your business entity, and the one that you are acting upon, you may want to react on some events. So whenever user enables some settings, you may want to send an email to the user, okay, like confirming you enabled that setting. This is what event handlers are for. They are kind of listening for the events, for the particular event types, and they are acting upon these events. It can be the same system, it can be different microservice, it can be different module in the same system. It doesn't really matter. What matters is that the read side is totally separated from the write side. And again, I hope that after this kind of introductions, like how the event sourcing works, you can see how that quote still stands. That's architecting for the future, for the tomorrow questions or future questions. Because you have this event log, and whatever happens, you are able to reply all the facts that happened on the business entity over time, since the beginning. And now, try to think about the past two features that I showed you. If we knew that we saved the log, if we had that log, if we saved that all the events, every time we got a skipped, we got a skipped adjustment, we got the adjustment that was actually executed or was skipped because of the ML or skipped because of the low balance. If we treat that information as an event, and only the events were our source of truth, so that we can rebuild our current state from stream of events, we would have all the data to give the business any report they want. If only we had the data. And if we had the data as a kind of side product, so we have this business, this main flow, which is kind of CRUD-based, and as a kind of side task, we are saving some data, I guarantee to you that sometimes it will happen that someone will either forget saving the data, or the inconsistency with the Kafka, sending to Kafka and saving to database will happen, or whatever will happen, and you will lose the data somehow. If you have the stream of events being your source of truth, you have all the data to work on. You can do any projection, you can do any time traveling, you can do any reports, any insights on the data that business may want. Granted, you have all the data in the events. So quickly, benefits of the event sourcing. Time traveling, I hope you saw that already, that you have this stream of events from 6 months. You can set up a kind of breakpoint at a given moment in time, and let's say 2 months ago, what was the state of the user account 2 months ago? You just replay all the events up to the moment in time, and you precisely know what was the state of the user account and what happened to that user account before. Time traveling, audit trials. So having all the data as form of events, you are kind of getting audit reports, audit informations basically for free. So any court trials, any auditing purposes for regulations, if you work on the finance industrial, stuff like that, you get it for free in this case. All the data inside, all the business reports, the business may want to go to you and ask after a few years, give me some reports since the beginning of the system working on production. You have all the data. It will take probably a few hours maybe to reply, to process all the events, but you have the data. You can do the reports. Scalability and performance and CQRS, it kind of matches the CQRS paradigm as well. As you saw on the pictures before, the read side is separated from the write side. Currently, the systems that we are writing usually, if you are not working on kind of IoT-heavy stuff, are read-heavy, not write-heavy. That means that you should be able to scale the read side way better and way more aggressively than the write side. And this is what it gives you. The eventual consistency, the read side that is separated, allows you to massively scale the read side up to now, like number of nodes, number of databases, number of database nodes, number of different database type, different storage type, different query types, and keep the right side being scaled in its own way. They don't interfere with each other. And also the event sourcing, it may look like it's complex in terms that it requires entire system to be rebuilt, but it's not true. To me, the event sourcing is kind of not a global architecture approach, so we cannot say about systems entirely being designed in an event source way. Event sourcing is just for particular domain or even subdomains in your projects, and it really shines in very complex domains where you'd have something more than comment like create account and the event is account created. It doesn't really bring much benefits from the event sourcing. If all the system, if all the flows that you're gonna build are like that. If you have complex domain, event sourcing will really shine. And if you have audit trails, and if you have in a highly regulated businesses like finance, like automotive, like aerospace or stuff like that. But it's not all that good. Event sourcing is kind of complex, especially if you come from CRUD approach, like just storing the state in a database and just updating the state, like doing database updates all the time. It requires kind of mind shifting and thinking in terms of events, like not what I'm gonna update, how I'm gonna update perform the database update in my database, but what actually happened to my business entity. Like to switch the mindset to think about what's gonna happen, and if that happens, how I'm gonna signal that thing that just happened, and how I'm gonna persist that to my event log. The next point, long-term maintenance and versioning. As you saw again on the pictures before, you are replying the streams from the very beginning. So it means that you need to keep all the information since the very beginning of the system existence. If your system lives on a production for 5 years, it evolved massively. Some commands, some events, some features are no longer supported. They are decommissioned. They are not used by users. Still, you need to keep the information. You need to keep the code to be able to handle, at some point, replaying all the events since the very beginning. It may introduce some complexity in terms of how we handle events, in terms of code base growing and stuff like that. But that's the kind of trade-off. There's no silver bullet. Again, as I said, it's best for complex domains or complex subdomains. And again, the question is if you are Netflix, if you are that scale, or if you are that complex, if your project is that complex that it really, that you'll really benefit from event sourcing. Maybe yes, maybe no, it's up to you. I mean, you can build CRUD system on event sourcing, but what's the point? And it really requires good domain knowledge. I know that we as developers, give me the problem, I will just code it to you. But before we start, we need to have a really good knowledge about the domain. So doing kind of event storming, domain discovery, in any other ways, workshops, domain modeling techniques. Apply whatever you can in order to know in order to get to know the domain better. Okay, so let's use the event sourcing. So Joe is heard about the event sourcing, read about the event sourcing. He got these two features that kind of failed. I mean, they were working, but he was unable to provide the data in order to kind of grow the company by tweaking some of the parameters to get more profit. So he's gonna use the event sourcing, and he's gonna model, let's say, the account in a way as it's shown now. We have account for the user. It has some list array of balances and some methods: deposit, withdraw, exchange, adjust, whatever. It doesn't really matter. That's only one way of modeling the account. And it's gonna work this way. There are a set of commands. They are issued either by user or by some automated scheduler for these adjustments every 7 days or so. And there are a set of events. For every operation, there's a set of events that are being appended to the event log, event store. By the way, what's the event store that I'm talking about, or the journal that I'm talking about? It's any type of the persistence that is that you can use in order to save all the facts, all the events for the user, so that you can, for example, when reading the user, you can like narrow the search for given entity, let's say, for given user account ID. So you don't have to bring entire database. You just fetch the stream of users, stream of events for a given user account. For example, we use Postgres at the moment. It's a relational database, but it's pretty good at handling event source. We use it with Akka. I use the Akka events, Akka persistence with a journal or event store that was backed by Cassandra as well. There was dedicated database event store DB just for the purpose of storing events from event sourced entities. There's tons of databases. You can build one on any regular, any relational database, MySQL, Postgres, whatever. You can build it on file, obviously not for production use. But I don't really encourage you to build production-grade event store because it's a bit more tricky than it seems. But the operations, like adding events, is just adding rows to the table. We don't modify anything. Events are immutable, so we are just adding stuff to the database. And any database will love to handle that kind of operations. So if you are not modifying the data, you're just adding to the database. So one of the options to model the account is like that. Series of commands, series of events, building this event stream over time. Few months, few years, depends. And again, domain discovery. Why is it crucial? Because we did pretty much similar mistake as on a previous slide. This is crucial because at some point you may figure out that when system is on production, you may figure out that there is some concept in a domain that you didn't see before, that you didn't discover before, and it may change the way that you structure your system, structure your entity, structure your aggregates in your event source domain, which will require you probably to rebuild, refactor, restructure the system structure, the aggregates, the domains that have these event streams. It's a bit more complex, or maybe way more complex than in CRUD systems, because on a CRUD system you just do flyway or liquid-based migration and you are done. In event source system you need to migrate entire event streams, which may be a bit more tricky. That's why domain discovery is way more important for me as in a CRUD applications. But also for complex domains, domain discovery is still really important, so you need to do it anyway. I mean, I would advise you to do it anyway. We have the system, the event source system on production. Joe has that adjustment and stuff on production. And then there is a Jira ticket at some point coming. User cannot top up account. User cannot deposit money or withdraw money to his account. So Joe is on panic at the moment because of this first issue with the event source system for him. And he has nothing from his previous tools from his previous toolbox to work with. Because usually when you have a CRUD application, you do this magic select. Select asterisk from table, where user account or user ID is 1, 2, 3. And then you know, basically, what's the user state because you have entire database row. You have all the fields, you know what's the state. You can see, okay, this flag was supposed to be set to true. It's set to false for whatever reason. You just do a database update. On production, YOLO mode, it works. And done. And then you can continue investigating stuff. But in the event source system, it's not that easy. Because in order to know what the state, what the account is, what state the account is in, you need to reply all the events. So we need to build a toolbox around your event source system. One of the tools that I usually have since the pretty much very beginning of the project is to be able to reply all the events for given entity, to know what happened one by one. So doing a select by persistence ID, but it doesn't give me the state, it just gives me the events. I need to apply the events one by one to the empty state. And I'm ending up with a state at the user at the given moment in time. So if we have this tooling, we can somehow figure out what's the issue. Okay, the flag was set to true, but it was supposed to be set to false or whatever. And we need to fix it somehow. Again, in a CRUD systems, it would be that you just go to the base, do the update, YOLO mode if you have access to production, or ask kind of operations to do that, and done. In the event source system, it's not that easy, because there is a kind of temptation to override the event. Like, you know, you located the particular event that somehow was miscalculated. There was an edge case, the flag in an event, the field in an event ended up being true while it's supposed to be false for whatever reason. So the easiest way would be just go to the database and override that one particular event, one particular field in this particular event. And my advice is don't do that, because treat events as a immutable stuff. If they were saved to the database, they are the facts that happened. You cannot change the past, as in the real life. You cannot change the past. They are immutable. Events are immutable. If you happen to change the event in a database, the user may work. The account may start working again, because the next reply would pick up the new flag. But think about it in terms of other systems, auditing, or any other reports later in the future. If your events that you saved were propagated already to some other systems, the other systems relied on the flag that the flag is set to true, while you change it to false. So now the data is inconsistent. So if you do your report on your side, you will show the correct value, but the system has the old value. You have no way to signal to the other system that something happened, that you do the manual correction. Also in the accounting, also in the auditing parts, we know that something happened, and we know that at some point the event was changed manually in a database. In some cases, there may be some legal repercussions from that. I mean, you may get fined, you may get sued for that. It really depends on the domain you are working with. The best option, it may require some work. The best option is to issue, again, treat the events immutable, so issue one more event, which is called kind of healing event, compensating event, that will change the flag, change the state of the user in a way that it should be done, in a way that to the kind of correct state. So in this example, change the flag from true to false, for example. What it gives us, I mean, it gives us a bit more work because we need to code all this stuff, because it's probably an event we don't have yet, with a command we don't have yet. But it gives us a clear picture. We know at some point, replying the event stream, we know, okay, there is that one event that corrected some mistake from the past. And we have all the data for that. And then in 1 year, when there is an auditing, if there is the other services requesting the projection from that, they will need to handle that particular event. They will need to act on that. And they will know that, okay, that flag was corrected from true to false with this particular event. And also, if you add that particular event, the other system may react on that event and do their work on that, probably correcting their own domains, their own storages, their own systems with the corrected flag. So don't try to overwrite events. I did it twice. One time it worked, one time it didn't. And I'm not going to do it anymore, especially on prod. I mean, on stage test, whatever, it's pretty fine. The other option is you can try to build a layer between events and projections and events and state to build kind of adapters, so that if that user and that transaction ID then flip the flag from true to false. But it will end up as a spaghetti mess at some point, like bunch of ifs, and you'll never know what happens. So fixing the event log is tricky, and it's usually the best way usually to fix the event log, the inconsistency in state, is by issuing this healing events or compensating events. Because it's kind of clear for the users, for the consumers of the event stream at some point that something happened, something was corrected. And then there's feature removal. After a few more months, one of the features that they coded in event sourcing didn't work out. They want to decommission it for some reason. Maybe they are no longer allowed to have the service, whatever. And there's a PR from Joe and his team removing 4,300 lines of code and adding just only 10. Looks like really cool PR. Like removing a bunch of code. Works on my machine, shipping that to prod. And then there is a disaster. Deserialization errors when entities are, when the aggregates, the accounts are trying to be replied. That's because they removed everything for the feature. They removed commands, they removed projections, and they also removed the events. Because they wanted to remove the feature. So why not remove the events if it's no longer there? I mean, we don't need it. But again, the long-running thing from the event sourcing systems strikes back. Because if you ever had the event in your event stream, you need to be able to handle that in the future. You need to be able to reply all the events from the very beginning to up to now. So if you have event handlers for some event from the feature that no longer exists, you may be able to remove the command handling, you may be able to remove business logic, you may be able to remove event handlers and projections, but you usually cannot remove the events unless you do a migration of the journal of the event store to kind of rewriting the events. But again, as I said before, that's not really a good option. So you need to keep at least the events. This is the thing that I mentioned before, that it may cause maintenance of event source systems a bit trickier because you need to care about the code that you had in the past, in the very beginning. Even if the feature was used, even in the event was written to the journal, to the event store only once, only for one user, you need to keep the implementation of it. You need to keep the handling of it because applying the event needs to work. You need to be able to apply the state, apply the fact that happened within this event to reply your event stream. So it's not that easy. You need to keep that in mind if you want to do some cleanups or changes. And the same happens in event versioning. If you change your features, if you refactor your features, if you add stuff to your events, if you want to change the way the stuff works, you need to still have at the back of your head what's going to happen if I try to reply, if my business objects are going to reply from the very beginning. Would I be able to reply all my events? And will all the events be applied to the current state correctly? Do I still have the event handlers for this? And that kind of links with the next point, which is requirements change. Over time, like if you have short-running projects, the requirements change may not be that big, but if you have projects that are running for 5, 10 years, there may be requirements change, feature may change, the number of messages in the event, numbers of data in the events change, the structure of the aggregate, structure of the business object may change. You may want to split one account, like from the previous model, into several different pieces, like one account, and for example, each transaction for given user would be its own event source entity. How do you express the event changes, like format of the event change in an event stream? Usually we use some schema-heavy protocols for that. We could use plain text, but this is going to be a disaster. We can use JSON, which is way better because it has a structure, but has no kind of enforced schema. So we can accidentally change the event payload in a way that's not going to be compatible with the past events. Because of that, we are using, for example, in my projects, we are usually using protobufs for that, because protobufs has kind of strict rules how the protobuf message, how the protobuf payload can evolve to be still backward compatible. And if we do the change that is not backward compatible, we need to handle that explicitly in our code. By generating the messages from the protobuf definition, we need to handle the changes explicitly in the code. This gives us some kind of safety net for versioning of the events. Because we can have different approaches for versioning. We can have different version of events, like, for example, whatever event v2, v3. We can just add the fields that are optional. We can just add a new separate event, or even new separate stream of events for given entity. If the requirements change drastically, it may look like it's totally new entity, totally new business process. It's no longer just plain account. It deserves its own event stream, its own events. So versioning in this case, because we need to keep the consistency and we need to keep the event handling from the very beginning, versioning is really crucial in here. Like last week, I just did a bug adding a field to a protobuf message that was backward incompatible. I mean, I discovered that in test, but still, that still happens. It may sometimes happen if you do like a bit more than one changes at the same time. It may happen that you just kind of mistype something and you will get a wrong event payload at the end. I mean, the new events will happily decode and encode, but the old events will fail to decode, fail to deserialize, to be replied to your and applied to your state. The author of event sourcing, Greg Young, has this book which is available online for free, I believe, versioning in event source system. The funny thing that the book is 80%, I believe, 80% finished since 2017, but still worth reading if you are into that kind of things. There are way more approaches to the versioning than I just show you. It's no longer not only the version number, not only the additional field, but it's about migrating entire event streams, splitting entire event streams, merging entire event streams, and stuff like that. So versioning is one of the tricky part in there, and it also links with the feature removals. You still need to be able. It kind of boils down to the point that you need to be able to keep the handling for old events. There's a new feature coming in for the job projects. They want users to attach like their bank accounts, so like periodically the company can kind of send money to their accounts. And the regulation is that the account number must be unique. It sounds like the strong consistency is required here. Like we need to do it in a database transaction somehow to be sure that it's strongly consistent and we still have the unique stuff. But again, in the event sourced way, as I showed you, there is this kind of eventual consistency thing between write model and read model. So how we can do that? If only we had CRUD, we would do it like that. Just create unique index and be done. And the feature done, we are good. In an event source approach, you can try to model a transaction in between writing to your journal, writing an event, and updating your read side, so that any of your validations related to account number uniqueness are strictly consistent. And you can model that atomic change. Like within one transactional operation, you can add the event and update the read model. So add the, let's say, account number to some table. That table has unique index. If the Unix constraint is violated, entire transaction gets rolled back. Effectively, we get what we want. But the tricky part is if you start overusing or abusing that and you want to update more read models at the same time. It's getting more fragile. It's getting slower because you need to coordinate 3, 4, 5 databases at the same time. And any read model failure, for whatever reason, will cause your event writing to fail. Do you really want that? Do you really want your write feature to be impacted by read side being inconsistent for whatever reason? I don't think so. That's why you need to, you'd like to embrace the eventual consistency. Not sure if it's visible. Yeah, it's pretty good. So in this example, we may want user to enter the account number. So if the user enters the account number, we save the event user assigned account number. That account number goes to this, goes as a form of event, goes to this event store and the read part here at the bottom. And that read part has that constraints, that unique constraints. Whenever that constraint is violated, the read side, that event handler, issues the command to the entity that the user account number is invalid and it should be blocked. With that, we have, again, one more event to handle. It looks a bit more complex than regular CRUD, but we have entire history of what happened. Whenever user assigned a given account number, and then whenever any other user try to assign the same account number, we have the event that the account number was assigned, but then it was validated to be duplicate. We have the events, we have all that stuff in our event source stream. And finally, having that, whenever product people ask for some reports about duplicated account numbers, for example, for fraud detections, we can finally tell them that, okay, we want to give them that report because we have all the data in order to build the report because we have all the events for assigning numbers, for accepting account numbers, and for rejecting account numbers because of duplication reasons. And quickly about the performance and scalability. I guess we get one more minute, maybe. Beware of long event streams, because if you have longer event streams, that's the issue that I showed you at the with the very first implementation, with the very first modeling of the account. If the account aggregate's gonna live for 5 years, for example, number of events, if the account is really active, the number of events is gonna be few thousands, a few hundred thousands, and if you try to replay all the events every time the command arrives, you will expect the slowness. It's gonna take way more and way more time in order to reply the events. That's why you need to rethink your domain and try to build the aggregates that are short-lived. There's more aggregates, more objects that are short-lived with the shorter event streams. There is an option to that that you can introduce as snapshots. So while having the longer event stream, you take the snapshot of the event stream like every 1,000 events or every 100 events, and you build the state from the snapshot and apply the events only from the moment the snapshot was taken. You take the snapshot and apply all the events that were past the snapshot. It's one of the options. It's usually the first solution to that, but again, it introduces some more complexity because you need to keep the snapshots consistent with your state, but it still may signal that you didn't discover all the domains the right way, because you have too long entities, too long event streams for your domains. Okay, and I guess we don't have much. One more I would like to talk about is the eventual consistency and exactly once delivery. There is no such thing as exactly once delivery. I mean, you cannot achieve the exactly once delivery with a regular system if you don't care about it, if you don't deduplicate, if you don't do stuff on your own. If there's a theoretical issue about the user transaction summary at some report being wrong, it's because some events were applied to the projection twice. If you do some math, you apply like 2 transactions twice, you have a skewed average, you have the skewed sums, you have the skewed number in entire report. You need to be sure that you detect the duplicates and you discard the duplicates, or you handle the duplicates in your logics in an idempotent way. Because of the eventual consistency, you never know. It's going through the network. You never know what may happen. You may get the same event twice, 3 times. At some point you will get it, but you may get it once again in a moment because it wasn't acknowledged. You need to be prepared for that. And that's basically it. There are a few more bonus chapters that I have, but I'm not gonna be able to talk about them. So wrapping up, I know that sounds scary. I would like you to give it a try if you have something that may be worth trying the complexity, that may be worth the complexity of event sourcing. Give it a try, see the benefits from it after some time on production. I see a lot. But yeah, mind the trade-offs, the ones that I showed you and a bit more that are still there uncovered. Thank you.